Hello everybody, and welcome to your Chem 113 review on identifying ionic compounds. My name is Jason, and I work for the ASU Tutoring Centers. Now, as I have been alluding to in previous videos, there are different types of bonding that'll be happening in Chem 113. There's ionic bonding, and there's covalent bonding. Those are the two major ones you'll be talking about. In this video, we're going to be talking about ionic bonding. So what ionic bonding is occurs between a cation and an anion. So the cation is the positively charged, and the anion is the negatively charged. And the idea here is opposites attract. So if you have a positively charged ion and a negatively charged ion, they're likely going to attract to one another to form an ionic bond. Okay? It's the idea of, like, imagine two magnets. You have the North Pole and the South Pole of two magnets. You hold them close enough together, they're going to connect to each other. Okay, so that's what an ionic bond is all about. Now, what elements tend to form cations, and what elements tend to form anions? So, as we saw in previous videos, elements in columns 1A, 2A, and 3A tend to form charges +1, +2, and +3. So elements in 1A, let's see, cations, elements in 1A, 2A, and 3A tend to be cations, whereas elements in 5A, 6A, and 7A tend to be anions. 5A, 6A, and 7A. Okay, it's not a hard and fast rule. It can go either way, but typically these columns correspond to cations and these columns correspond to anions. Another way to think about it is typically metals are your cations and non-metals are your anions. Again, that's not perfect, right? I mean, hydrogen's not a metal, but it still usually acts as a cation. But it's a good general rule. And that also helps us with identifying exactly what happens in here in the middle portion. Your transition metals, that's what these are called, tend to form cations and not anions. So thinking about it in that way of metals versus non-metals is also usually important. What about column 4? As I mentioned in the previous video, column 4 tends to not really form ionic compounds. It can. When it does, those elements can act as either cations or anions, right? They're sort of in the middle. They can go either way. So there's not really a hard, fast rule for column 4A, but just be aware they can form ionic compounds. They just tend not to. So with this in mind, let's break down each of these. N2O. So we find where N is, it's right there, and we find where O is. They both have negative charges. They're both anions. Therefore, N2O is not ionic. Right? Because to be ionic, you need a cation and an anion. If you have two anions, it doesn't work. Okay? So it's not ionic. Now let's look at Na2O. So we have sodium, Na, which is over here, and we have oxygen. Sodium is a cation, it has a charge of +1, and oxygen is an anion with a charge of -2. So Na2O is ionic. Okay, let's move over to calcium chloride. We'll go over naming in future videos. So where's calcium at? Calcium's over here with a +2. Where's chlorine at? Over here with a -1. So we have a cation and an anion. So CaCl2 is ionic. And then our last one, SF4. So where's sulfur at? Sulfur is over here in column 6A. And where's fluorine at? It's over here in column 7A. They're both anions. They're both nonmetals. So this is going to be not ionic. You need an anion and a cation. So there you go. That's how you determine if a compound that's given to you is ionic or not. And the ones here that are not ionic are most likely going to be covalent, which again, we'll talk about in future videos. Wonderful. Well, thank you for watching. As I mentioned at the beginning, I work for the ASU Tutoring Centers. If you want more information about the free services we offer on all 4 major ASU campuses and online, please check out tutoring.asu.edu. If you want more information about videos that go over specific concepts from your course, or maybe you want to see what upcoming review sessions we have for the exams in your course, go ahead and check out that link below. Again, thank you very much for watching, and I hope you have a fantastic day.